Good afternoon and welcome from West Texas A&M University's Hastings Electronic Learning Center, one of the best facilities in this region, and they have excellent staff who are always adding value to this university's operations. And before I start, seminar, we always forget to recognize one person. Behind the camera, we have Mr. Tariq Johnston. He has helped us many times in the last 4 years. So we need to appreciate all his help. And this is another one of those seminars which is related to international marketing. This is the class I'm teaching. And we have two distinguished guests. They are our colleagues, and they are experts in their area. So let me go with the first speaker. I will introduce you, but our first speaker will be Professor Carolyn Bouma. She's Associate Professor of Biology. Our first speaker, introduction, Dr. Emily Hunt. She is a faculty member, researcher at West Texas A&M University, and she developed an idea to protect soldiers and civilians from biological weapons of mass destruction such as anthrax. Dr. Hunt was awarded from the National Science Foundation, which is one of the top organizations in this country, and Department of Defense, Washington, D.C., to pursue antimicrobial research. She performed the basic science necessary to transform the idea into a working prototype. Their current research focused on antimicrobials to create simple, safe, and effective solutions that protect people and assets from the dangers of microbial contamination. And she is also one of the co-researchers to develop copper clean antimicrobial service patches. You may have seen these copper clean patches all over the campus. Dr. Hunt joined WT in 2005. She teaches primarily thermal fluid sciences, including fluid mechanics and thermodynamics. Dr. Hunt's research includes energetic and explosive materials, reaction, synthesis, high-speed infrared imaging, and engineering education and assessment. Pretty heavy-duty stuff. Dr. Carolyn Bouma is an associate professor of biology at WT. She earned her PhD from Johns Hopkins University, one of the top schools in this country, biosciences. And her area of research includes microbiology, molecular biology, biochemistry, all these disciplines. She's an advisor for the pre-medicine program at our university. And these two speakers will help us understand today's ongoing crisis, which we have discussed in this class's coronavirus crisis. Let me say a few things about the issues, and that is so much has been happening, which we never witnessed in this world for the last many, many years. And basically, it all started in China, Wuhan. And from business point of view, and this is where international marketing comes in, it has created a lot of disruptions, supply chains, and your logistics. So it has a very big impact on multinational corporations. So in addition to biology, in addition to mechanical engineering and other research issues, we will also discuss some of the global perspective. What's happening in this world? How did it show up? And what exactly it will do. And I will also share with you some of the data losses and some of the companies which have been winning in this crisis. So at this time, let's start from Professor Carolyn Bouma, and let's give a warm welcome to her.
Hello, everyone, and thank you very much for inviting me. It's a pleasure to be here with you. I'm going to go over a little bit about the basic biology of viruses and also extend that to the SARS coronavirus 2 as we know it. And I'm not going to spend much on the epidemiology because you have a great timeline in your program there. but I will do a little bit on that, and then we'll discuss a little bit about the origin of the virus and where we stand going forward to mitigate this virus. Okay. So where are we right now? Where do we stand? As of yesterday, the numbers I pulled from the CNN COVID tracker said that the United States has 7.1 million cases and almost 205,000 deaths. That's a lot. And in a way, you could say the US is number one, but maybe this is a situation in which we don't want to be number one. In Texas as a whole, again, as of yesterday, over 750,000 cases, almost 16,000 deaths. You can see that epidemiology curve there. To put it in perspective, I thought CNN had a very interesting statistic last Friday about COVID deaths. Our current US COVID deaths are equal to having the 9/11 attacks for 66 days in a row. And since February 6th, our average death rate has been 858 deaths per day. So if the total numbers are not staggering and enough to impress you, perhaps those would make an impression relating to events that have happened in our lives recently. Okay, so a little bit about the basic biology of viruses. Viruses are not cells. Scientists consider them instead to be infectious particles. And this is because they cannot reproduce themselves on their own. They must be inside a host cell. And also, they do not respond to any environmental changes on their own. So viruses are considered to be infectious particles. Whatever the viral genome is made of, whether it's DNA or RNA, that is coded with protein, which is encoded by the viral genome. And some viruses also, including the SARS coronavirus 2, have a lipid envelope on the outside. So it's a membrane in which proteins are embedded. And so this is an actual electron micrograph of the SARS coronavirus 2 from the NIAID. In order to reproduce, viruses have to enter an appropriate host cell. In the case of the SARS coronavirus 2, that typically, at least initially, is a cell in the respiratory tract. Once inside the host cell, the virus uses the host cell's enzymes and the host cell's energy and the host cell's molecules to reproduce itself. So basically, it co-opts the host in order to serve its own reproduction. For the SARS coronavirus 2 specifically, I have a cutaway diagram shown on this slide. So on the interior, the genome of the virus is made of RNA, and it's coated with protein. Then this virus also has a lipid envelope surrounding it, within which some viral encoded proteins are embedded. One protein that I specifically want to bring to your attention is the spike glycoprotein, or also called the S protein. This protein is critical for the replication of the virus because it's the protein that the virus uses to attach to the host cell. And that's also an important protein because it's the protein to which vaccinations are now being developed. Okay, so this SARS coronavirus 2, like all viruses that infect humans and animals and plants, etc., must enter a host cell in order to replicate. And it basically takes over the host cell's machinery to do that. The SARS coronavirus 2 uses that S protein or that spike protein to bind to, typically initially, a cell in the respiratory tract. And it binds to a protein called ACE2, which is present in high abundance on respiratory tract cells. So the virus attaches to that ACE2 protein using its own S protein, and it's taken into the cell. From there, the viral envelope is opened and the viral RNA is released. Now that viral RNA is just like messenger RNA in any cell, and it can be translated immediately to make the viral proteins. So the RNA is translated. Some of the proteins are inserted into the endoplasmic reticulum and the Golgi apparatus of the cell. And as they are processed, that produces the new envelope for the virus. As the proteins are being translated, the viral genome is also being replicated. So then this whole thing sort of undergoes a self-assembly process such that the viral genome is packaged and surrounded by the new envelope with all the proteins in it, and then it's released from the cell. So once again, these viruses are not living cells. They simply co-opt the host cell's machinery in order to replicate themselves. And in the case of the SARS coronavirus 2, once it's released from a cell in the respiratory tract, it can be released out into the environment through respiratory droplets or aerosols, or it could also go to other places in the body, as we'll see. So as you probably know from the news and all the information that scientists know about this virus, the SARS coronavirus 2 is spread primarily by respiratory droplets. So since its primary site of replication is in the respiratory tract, when we cough, sneeze, speak, etc., those microscopic droplets are released and can be inhaled or drop onto surfaces nearby. And so it's this droplet transmission from coughing, sneezing, these larger droplets that, if inhaled by another susceptible host, could cause infection in that individual. And it's also suspected, many studies have shown, that aerosol transmission can occur as well. So these are the very small microscopic droplets that one could also inhale. If the respiratory droplets fall onto an inanimate surface, such as, the computer desk in front of me, someone could touch that, rub their eye, rub their nose, rub their mouth, etc., and that would be a way of viral transmission as well. Medical professionals have also documented that the virus is shed in urine and feces. That is not considered to be a major mechanism of transmission, but the virus is present in those fluids. Okay. Now, moving on, as far as symptoms go, I'm sure you're aware that the main majority of symptoms are relatively mild respiratory tract symptoms. They can become severe in some individuals. So this can cause fever and chills, in addition to the coughing, sneezing, sore throat, etc. Also, flu-like symptoms that would include muscle aches and joint aches. Some individuals experience nausea, vomiting, and diarrhea. And also it's been noted as an effect of the COVID-19 disease that individuals can lose their sense, or at least have a decreased sense, of smell and taste. And unfortunately, in some individuals, this has lasted a long time. But lethal disease is also possible. And that's what makes this COVID-19 so very dangerous and far-reaching in its consequences. So the COVID-19 symptoms, the manifestations of this infection are quite protean. And the Wall Street Journal had a description of it that I thought was quite telling. The Wall Street Journal early in September called it really diabolical. And we know that because not only of its effects on our medical situation, but on our economy and on our own lives. So this virus, while it does normally infect the respiratory tract, it can have a more deadly consequence of causing a pneumonia and inflammation and scarring in the lungs. It also can directly infect cardiovascular tissue, causing inflammation of the heart muscle, can cause blood clots, heart attack, and stroke. It also can infect the kidneys, causing renal damage or renal failure. And it's now been found that it can affect the nervous system, directly infecting the brain and causing encephalitis, which is inflammation of the brain and spinal cord. It can cause seizures, and it can cause a viral meningitis. There have also been patients who had a gastrointestinal infection. And they thought the initial infection was a gastrointestinal site, not the respiratory tract. So these first 5 body systems here, the respiratory system, cardiovascular, etc., those are all sites that can be directly infected by the virus, meaning the virus can replicate in those tissues. As a result of complications in other body systems, though, as an additional effect, COVID-19 can also affect the liver. And then in children, one syndrome that's been in the news lately and discovered because of COVID-19 is this multi-system inflammatory syndrome in children. Basically, it's like a whole body inflammation. that causes complications in many different body systems. So this virus can have from benign or asymptomatic disease to something that is very rapidly lethal. And so that really diabolical description is quite appropriate. Where did this virus come from? How did we get it? Why is it affecting us so much? Well, the SARS coronavirus 2 is a member of a family of RNA viruses called the Coronaviridae. Okay, so it's known to be a member of this family. That family includes the SARS virus that affected China in 2003, and it also includes the MERS virus, the Middle Eastern Respiratory Syndrome virus. The origin of this virus is hypothesized to be from animals, and that overall the virus sustained several mutations that have allowed it to jump into an intermediate animal host and then to humans. And much like the flu virus can change and slowly mutate over time, so that once in a while we get a very severe flu season, similar thing apparently has happened with this coronavirus. The genome sequence that was released by researchers in early January 2020 shows that the virus is most closely related to coronaviruses that are present in bats. So that's the hypothesized origin of this virus. So it's a zoonotic virus. It is not derived from a laboratory. Scientists who have studied the sequence of this virus across the world do know that it's not lab derived, because to make a laboratory derived virus, they would have to splice together genes from several different sources. And that just is not what appears to be the case with this virus. So it's hypothesized to have originated in bats and then mutated and gone through some intermediate host that then allowed it to sustain further mutation so that it could infect humans. That intermediate host is not conclusively known. For the SARS 2003 virus, it was a civet cat, and that's just a little shadow of what's shown here in this diagram from the Wall Street Journal. But the pangolin is another animal that is proposed to be the intermediate host for this virus. And so it is not known for sure that the pangolin is the intermediate host, but it is known that the first victim of COVID-19 in China did have close contact with wild animal meats at that market in Wuhan, China. So all that being said, it's a bad disease. We're getting some idea of its origin. Where are we going from here? So currently, through the support of Operation Warp Speed, there are 4 vaccines that are in phase 3 trials in the US. 2 of them are viruses themselves, I should say, include viruses themselves, which we hope would generate herd immunity. The other 2 are RNA vaccines. So just a little bit about what we mean by that. The AstraZeneca and the Johnson & Johnson vaccine are a very low virulence adenovirus vector, which means that normal respiratory tract virus has very low potential for causing disease because it's been mutated, but it has the spike protein, that S protein, from the SARS coronavirus 2 inserted in it. So the genome of that adenovirus has been changed to include that the gene for that spike protein. And the idea is that the individual receiving this vaccination will produce that S protein, and their immune system will recognize it as foreign and develop antibodies against it, which would then neutralize a future infection by the SARS coronavirus 2. So the little schematic on the right here just shows this would be the S protein. This would be an antibody produced by the vaccinated individual. It would bind to that S protein and block it so the coronavirus could not enter that person's cells. The other 2 vaccines in phase 3 trials are what we call mRNA vaccines. These actually contain the RNA that encodes the spike protein, and it's packaged inside a little lipid particle, what we call a liposome. So it's packaged inside a microscopic lipid particle. When delivered by injection, that particle then fuses with the membrane of a host cell and is taken in. That RNA would then be transcribed to make the S protein. That S protein is produced, the immune system recognizes it and produces antibodies against it. And once again, those antibodies would block the S protein on the real SARS coronavirus 2 and provide immunity. Main difference between these two types of vaccines is that the RNA vaccines do not produce herd immunity. They do not produce herd immunity. So they're only good for that person to whom they've been administered. And of course, we're going to face challenges for distribution of this vaccine or these vaccines when they are approved. Who gets them first? How is the shipping going to happen? Who administers them, etc. So those are things that have to be worked out. And in the meantime, it seems like this disease is not going to leave humanity anytime soon. So we'll need to continue with using masks appropriately and with our social distancing as we've been doing to decrease the spread. Thank you, and I appreciate you inviting me today.
Let's wait for the last 15 minutes, but let me invite at this time our second speaker, Dr. Emily Hunt. She's also the Dean of our Engineering School.
Thank you for having me today. This timing is perfect for me to go after Dr. Bouma explains all of the science behind the coronavirus and how it's actually structured and how it's spreading. And Dr. Bouma and I have worked together on so many different parts of research over the last several years. And some of the things that I want to talk about today, we've worked together as a team on so many things. So I come from a mechanical engineering perspective and instead of a biological perspective. So much of what I learned has been from working with different microbiologists and with Dr. Bouma specifically. So I'm honored to be here and get to present with you today. Okay. So I began working in nanomaterials in the early 2000s. For some of you, you were just born in the early 2000s, right? And that's when nanomaterials specifically became its own field. And what we realized is that when we take a material down to the nanoscale, which is just one scale, like 10 times larger than an atom, when we go down to that scale, materials have all different properties. So they even are different colors. So when we think about silver, for instance, we're going to talk about silver some today. Silver is actually purple when you take it to a nanoscale. And you have all of these different changes occur, but not just the colors, but how they perform from a mechanical perspective. So when I talk about strength or ductility or the different things you would think of with a structural material, when you go down to the nanoscale, all of that changes. And so it was really opened up a new field of material science for engineers in the early 2000s when we started to look at these materials and look at how we could use them. Specifically, when we talk about energetic materials, which is where I started, it changes your mindset from thinking about using a fuel and an oxidizer for a fire, right, to produce gaseous products. We figured out that there is so much chemical energy stored in nanomaterials, in nanoscale materials themselves, that we could actually have a reaction, which would normally you would think of as your fire or your explosion, but what we're left with is a new solid alloy. And this was an incredible thing for us at that time. In 2008, the Defense Threat Reduction Agency issued a call for proposals to develop materials that would combat weapons of mass destruction. At the time, I had been working in research on materials that would resist some types of microbial growth. And so we quickly transitioned to start looking at these specific microbes that would act like anthrax, for example. Anthrax is kind of the most common one that we all connect with, but there are several different types of spore-forming bacteria that are harmful as well because they can go into a dormant state and they can resist extreme conditions. So they can resist explosions or freezing or all kinds of different things. The Defense Threat Reduction Agency works outside the borders of the U.S. to neutralize any kind of microbial or biological warfare development outside our borders. So when you think about trying to neutralize a threat to the United States outside of it, you wouldn't just want to make it explode, right? Because if they're producing biological warfare, you would just be blowing that out everywhere. And so we were looking at how do we neutralize threats without endangering the areas and people and communities around where these different facilities were located. This was a very exciting work for us. As engineers, when we worked with nanomaterials, we started to realize that instead of taking a material that we already have and know about, we could build a material that we need. So we were really intrigued and challenged by the idea of how do we build a material from the atomic level up that functions against harmful microbes? How do we optimize the properties of nanoparticles to get an end result that's functional and is ideal for our application? So what happened is we actually developed two types of materials for the Department of Defense. One was a gaseous material and one was a solid material. When the research contract was done, we turned the science, we turned our results back over to the government, and they then utilized it and still utilize it in gas mask technology. At that time, we were able to commercialize the product. So what we saw is that yes, in this specific instance, the government has a need for this product in a military aspect, but we could already see so many different commercial uses for a material that would protect against harmful microbes, whether that be bacteria, which is what we worked on most of the time, or viruses, which is what we talk about now. So as engineers, the way that we work, we learn in college a problem-solving methodology, and we apply it to almost everything in life. It actually kind of changes our brain where we can't even respond to normal situations without taking it through a quick problem-solving loop. But what we do, we have some kind of ideation, or we see that there's a problem. Next, we take it and we use what we know to start to develop some product solutions, some problem solutions. Then we prototype, we test, we manufacture, and then we can actually deploy a solution into the market. So this was the first product that we actually, so we formed a company, and this was our first product that we launched into the marketplace. It's interesting because I gave a presentation to a group of business owners a year ago. And as an antimicrobials company, that's what we do. We were talking about antimicrobials in the marketplace. And it was the first time some of them had heard the terms microorganism or bacteria or virus since college, right? Nobody cared. And what's crazy is that 1 year later, my kindergartner knows what a fomite is. They understand more than ever, right? I mean, just people in general, worldwide, we understand and we're aware of high-touch surfaces that we share with other people. We're aware of just the things that we do and we touch and interact with. We're wearing masks, we're social distancing. All these things have just changed in a year. So when we first launched a product into market, our product was called MicGuard. And we did some extensive testing, primarily with Dr. Bouma, to develop this product, but it was used primarily to protect infrastructure in different industries throughout the US. So we're talking about US and worldwide, actually. So when you talk about the oil and gas industry, and we're looking at pipelines, you can see this top picture here is actually a pipeline that's been attacked by bacteria. You don't think about that, right? You don't think about bacteria causing corrosion. When you hear corrosion, you think rust, or you think of some kind of chemical interaction or oxidation. But more than 40% of the corrosion that we experience in the US is caused from bacteria. Now, when you think about oil and gas, you think about a pipeline, it's in contact with the air, with water, with soil, with all different environments where bacteria live. And so two different things can happen. One, there are actually bacteria that can eat through solid surfaces. Most of the time what's happening is that we're forming a biofilm inside of the pipe. Bacteria are attaching to the biofilm and then they're producing harmful gases that end up corroding the pipe. And then you get failure, structural failure. This happens too when you look at infrastructure, transportation industry, bridges, all different kinds of things that we rely on as a country are corroded or destroyed due to these harmful bacteria. So we developed this material, MicGuard, And the second picture shows you a pipeline that's actually protected by Midgard. We've had pipe in the ground for a long time now. And so we have some really good results on how we're actually protecting against this. So this is one way back then, I mean, even just a couple of years ago, how we were protecting against harmful microbes. Another product that we have is called FoulGuard, and here we're actually preventing hard shell fouling. When you, how many of you have heard of hard shell fouling? It's kind of a different concept for us up here in West Texas. We understand oil and gas, right? But thinking about things that are hard shell fouling. So when you think about offshore oil and gas, we can go back to oil and gas, but talk about offshore. So pipelines are going to be coated underwater in some kind of polymer structure so that they just don't get completely corroded by seawater. But what happens to the say plastic that they're coating them in is that ocean life starts to attach to it. And eventually with that kind of weight, you also have a structural failure. And so when you think about ships in the ocean, when you think about all different kinds of things experience hard shell fouling. So this picture on the left is showing you a panel. All of this testing is done in Tuticorin Bay off the coast of India. It's supposed to be considered the highest fouling region in the world. So sometimes one day of fouling in Tuticorin Bay can be equivalent to a year of fouling in other ocean waters throughout the world. So it's very high foul rate. But this shows you on the left-hand side, we have a sample that is not protected with FoulGuard, and on the right-hand side, we have a sample that's protected with FoulGuard. And so we know that we can develop these materials that are protecting against harmful microbes both in and out of the water. So as engineers, logically, we're being able to develop materials that are protecting different infrastructure in large commercial environments. We wanted to do something that was relevant for homes, for households. So when we had the hurricanes in Texas a couple of years ago, we were actually approached by an outside group that asked if we could develop something that would help remediate the mold situation. So after a hurricane, decades even after a hurricane, mold is still the most prevalent issue that people deal with. They estimate that 47% of homes in the US have some kind of mold problem, which again, in such a dry region where we live, we don't always think about mold in our homes, but it's there and it's true. So we have a product that we developed called PaintGuard. PaintGuard it's a small tube of liquid that you mix into a gallon of paint, and it will prevent mold growth. Our the longest testing that we've done is up to 2 years. So we know that we can prevent mold growth for up to 2 years is what we can claim now. So this is EPA approved. We have gone through all kinds of testing with it, and it's probably our easiest, most practical product to use. Sells every day because people are becoming more and more aware of different organisms that are living in our homes right now. Okay, so what happens is we are an antimicrobials company, and let me also say that the patents for our company are owned by the Texas A&M University system and by West Texas A&M University. So we develop patents, and we have undergraduates, we have graduate students, and then we have full-time engineers that actually work in the lab and with the company to develop products and conduct research. So it's been a really great model for us. And what happened is that in January, we started to see the results of things that were coming out of Wuhan. And we knew as engineers, just like when we had the hurricane and we knew that there would be fallout and there would be a need for some kind of antimicrobial, when we started to see this happening, we knew that at some level we were going to have to be able to produce some kind of product that would protect against viruses. This is new for us. We had done most of our work in bacteria and in mold. However, we had started working on a prototype for a similar product to what we've launched during the pandemic. And so we had done some initial research on it, and we had prototypes in testing. We knew at that time things weren't shutting down yet. We hadn't seen what would actually happen over the next 9 months. But as engineers, you're very aware of problems that are occurring, and it's almost impossible for us to not immediately start working on some kind of solution. So when we saw this happening, we knew that in order to move forward, we were going to need to be able to launch some products into the market during a really questionable time in the market. And Copper Clean is our product that has come out since then. So Copper Clean, it's a very straightforward product. It protects surfaces, high-touch surfaces. So Dr. Bouma talked about how we can cough on our hands, we can touch the mouse, then I can rub my eye and we can easily spread it. So when we think about door handles, when we think about railings, and we think about elevator buttons or grocery shopping carts, when you think about the Skylink at the airport, like all kinds of different things where you're sharing a surface with other people, we wanted to develop a product that could be easily implemented and actually protect people that we know. Like we were wanting a solution for our next door neighbor, our friends who own a business. We wanted to be able to find something that could help this. Once we launched this, it was actually late March, early April. And so we were already looking for ways that we could keep certain areas of industry open, but then also ways for businesses to be able to communicate to their their consumers, their employees, their customers that they care, that they're doing something to protect their businesses so that they could reopen at that time. So this is Copper Clean, an antimicrobial surface patch. So what happened is that we started testing with copper particles, nanoscale copper particles originally. We were incorporating them, we were using an alloy because the things that we know about copper are, it's been an antiviral since ancient times. Antiviral, antibacterial, like antimicrobial. You think about water systems in your house that were made copper pipes. Has anyone ever seen copper pipes? So copper has been a known antiviral for a long time, but when we are able to use nanotechnology, we can take some of the inherent, I won't call them weaknesses in copper, but the things about copper that make it hard for us to use. Copper is very soft. It's not very structurally sound. Copper patinas or oxidizes very quickly. Statue of Liberty is what color? Green, and it's actually made out of copper. So we know that this material exists, that we can optimize on a nanoscale by incorporating other materials with copper particles so that we can resist some of the corrosion and patina, so that we could strengthen the product so that it could last longer, and so that we could optimize it for what we call extreme environments. So even here in the panhandle of Texas, we can swing 30 to 40 degrees temperature-wise in one day. So when you launch a product into the market, you have to be able to answer questions like, how will it withstand our water? How will it withstand cleaning products? All of these different things. So we were able to actually take copper and we were functionalize it so that we could use it during this time. This part of it was fascinating. So in April, we got the first research studies out that were looking at the SARS-CoV-2 virus, looking at it specifically with regard to hard surface or solid surfaces. And every article that came out said copper is the only thing that's effective against it. Copper is the only thing mitigating. On cardboard, on plastics, on stainless steel, it was living for days. And on copper, it was living for 4 hours. And 4 hours seems like a long time, but not when you look at the number of virus particles that they were actually putting in the test. So from the very beginning, copper was the best choice against the coronavirus for solid surfaces. So this talks about our proprietary alloy. We have 2 different patents that are pending on these products, these Copper Clean products right now. Again, owned by the university and the system. We are EPA approved from the ground up. So from the mine where our copper is first originates, all the way through to our lab where we're processing it for actual use. The whole process has received EPA approval. Interesting to note, our EPA approval is for bacteria because EPA right now is not issuing approvals for the specific coronavirus right now, the SARS-CoV-2. So that's in the process. That will happen over the next few years. People have been working to get copper EPA approved for viruses for a while now, and I think this is probably the impetus for that. But at the moment, when I am marketing my products, I have to be extremely careful about what I say. Nothing that I put out that is written can say that this this material is effective against the coronavirus. We know it is because they've tested it in labs, and it is, but your research results are different from what EPA allows you to claim. So from a marketing perspective, that's been very interesting for us because we have to really toe the line as far as what the EPA says that we can say about a product when we're advertising it. I won't go into this really in detail because, again, you can see the copper. I mean, you can see the virus cell. It has the spikes that she talked about, which now I feel like I know all about, even though I didn't just a minute ago. But basically, the copper at the surface is it's effectively dissolving some. It's leaching some, releasing ions. Once these ions get inside, then they produce a reactive oxygen species, and they can prevent the cell from prevent the virus from being able to continue on and live in the cell. Our products are very easy to apply and maintain. We wanted to have something that you could get in the mail, take out of the package, put on, and have an immediate solution in place. So we have on our website, we have very specific videos on how to apply it, how to clean the surface, and that kind of thing. And you guys can look at that because I'm time-wise going to need to. We have standard sizes. So we have the universal surface patch. I'm not sure if any of you have seen these on campus, but we have quite a few of them on campus. The universal surface patch is made just for a pull or push door. It's larger than a hand, an average size of a hand. But the lever handle patch, this is our most commonly sold patch. We thought the universal surface patch would be, but this is apparently what most people have. So these right now we're in all kinds of different industries. Larger surface patch, we had some commercial real estate companies that needed larger ones because they had really large door handles. And so now we're selling quite a few of these, but we're in all kinds of different industries: education, healthcare, movie theaters, restaurants, some airports, all kinds of industries that you can think of that would need to be able to show employees and customers we're doing something during this time to protect you and to stay open. And then we also do all kinds of customized. We did some customized car handle latches for lift. We do all kinds of phone patches all the time. We have push plates for bathrooms. We have crash bars, all kinds. As engineers, we love a new idea and a new way to develop it. Okay, and we're saving that till, yep. All right. Thank you for having me here. I could talk about this all day. We love the idea of developing solutions to problems, but I appreciate your time.
Good afternoon again. I will wrap up and I will show you some of the business related data, what's happening in the world and in what way it deals with international marketing. So basically, as we discussed, the virus started in Wuhan, China, which was discussed by Dr. Bouma. And then CDC confirmed first COVID case in the US. That was Seattle Tacoma Airport. Somebody had come from Wuhan. And China closed its city under strict total quarantine. And World Health Organization declared this emergency. I mean, all this data you already know from the media and in the last few months. And then interestingly, on March 27, 2020, United States Congress passed the Coronavirus Aid, Relief, Economic Security Act. It's called CARES. And they allocated $2 trillion. That's a lot of money, first time in the history. And on September 25th, there were 32 million cases. We discussed it. And let's look at some of the business related issues. So basically, because of demand, because of consumption, Amazon hired 175,000 people. That's a lot of, big crowd in terms of human resources. So who are the major winners in the last 8-9 months? It is Amazon, it is Zoom. We have been using Zoom in this university and many universities are using it. Big box retailers, Colorax, Top Glove is a glove manufacturer from Malaysia. But then we also need to look at the industries which lost. Airlines, clothing stores, restaurants, ride-hailing companies, Uber, Lyft, movie theaters, hotels, casinos, and Google also lost, not in terms of search, but its ad. And so the biggest increases in spending happened in online consumption, groceries, electronics, and subscriptions, home furnishing, internet, video streaming. From marketing point of view, we need to understand which businesses are thriving. On the other hand, there are lots of businesses, they also lost. So basically, COVID-19 had a mean infection rate of 2.5. September 2020 cases are 7 million. India has 5.8 million because of population. Brazil has 4.65. And then total cases coming out to be 32.9. The issue of R number is kind of controversial. I just had a little discussion with one of my colleagues who's a professor at Texas Tech, and he's a medical doctor, and he said that we should not rely too much on R number, reproduction number, because many countries, politicians capitalize on the R number, and they talked about that if the R number is going down, we are doing okay. I think it was highly politicized, so now not too many people are using the R number, but it's a big issue. Let's look at the supply chain disruption. It is truly a global crisis. If you apply international marketing, any kind of business field, pricing strategies are a very big problem, price sensitivity. Multinational corporations alone employ 42 million people. All your cell phones, iPad, iPhones, mostly they come from China. And there was a very big disruption in the last 6-7 months. And then we also saw a very big disruption in terms of foreign direct investment. And it applies to global business. And then it also impacted global value chains, a very big problem in this world. And it is still going on. Eventually, virus will disappear, we all know. In this year, by the end of this year, a vaccine or vaccines will show up. And I will show you in a minute some of the issues in vaccines. And according to Bill Gates, and there are many experts, they are predicting that by the end of 2021, virus will be controlled and we will come back to our normal life. Of course, we will continue to wear masks, as our distinguished speakers mentioned, because the virus is not going away. We have unprecedented challenges, closing of factories, disruptions in transportation, labor disruptions are a big problem, but all your airlines have been stranded and there is not too much business. We never saw in the history of this country and other countries where this kind of disruption happened. Now let's talk about the vaccine. It's a very big research area, as Dr. Bouma mentioned, but these are the companies. She also shared this data with us. Johnson & Johnson, Pfizer, BioNTech, Novavax, AstraZeneca, Sanofi, GlaxoSmithKline, Moderna is from Cambridge, Massachusetts. And then we have Russia versus China. That is another competition going on. And in the last few weeks, Russia and China, they already started to provide the vaccine in their countries, because it is kind of a vaccine race. Forerunners are advancing quickly. Product development is very fast. Role of the FDA is also very good. But I was reading it the other day that companies pledge to stand with science on coronavirus vaccines. One thing which has developed in the last few months, it's called vaccine nationalism. And many countries are starting to fight. I will share with you this title I bought the other day, and it is called The Vaccine Race. And it is written by Meredith Wedman. It's a very good book. It was also reviewed on NPR the other day. And it talks about some of the things. So your vaccine race is basically like who's going to win this Olympics. And it deals with the big national pride. In fact, it becomes part of your national comparative advantage. So right now, it is kind of a race which is not going anywhere. but sometimes we call it Vaccine Olympics. There are some data sites, and I also prepared this 4-page handout for you. And it has some of the literature and data sites, and these are pretty useful, and it has some of the most current literature. But I would like to share with you, there are 2 data sites which are extremely important. One is managed by CDC, and the other one is managed by Dr. Bouma's alma mater, Johns Hopkins University. It was just a casual project, but now it became a very serious project. Consider going to these 2 sites. I think if you are interested in these, but a lot of things are going on. There are so many articles published by the New England Journal of Medicine, and then we have Lancet, and then we have Cell. All these journals, they write in layman's language, and the subscription is not all. Most of the articles are open to anybody. But in terms of literature, there is no shortage of literature. I have collected literature boxes after boxes on this topic, because we, from marketing point of view, look at the product development and how companies come to market and what kind of national competition issues will happen. So scientists will look at the biomed science, and then research issues in engineering. Researchers look at how to develop things, but we look at things, how to go through the vaccine, because you have to, at the end of the day, you have to show your return on investment. If you are investing $1 billion on the development of vaccine, you have to also recover your costs. So that's why one of my data showed that the price they determined was $4 to $21. I don't know if they are going to stick to that price, because when you go beyond this country, the price may go up. And then Dr. Bouma mentioned about the logistical hurdles. You cannot just take this vaccine and deliver it to other countries. You need to have the right temperature, and then logistical issues and delivery and all these. It's a very complex deal, that's why. But at the end of the day, what we think is, eventually this virus is going to disappear. We will come back to our normal life. But then the whole process had been very, very interesting. And geopolitics became a very big part of this whole crisis. And geopolitics, I'm talking about United States and China, and then Russia, and then Brazil. If you look at the issue of Brazil and other countries, they openly went for herd immunity. And they openly wanted to have people being exposed to this virus. And I mean, that's another debate, but we could have easily have a one-day seminar on this topic, although we only had 1 hour and 15 minutes, but we tried our best. But the topic is never ending. The literature people are still producing in almost every discipline you look at. There are papers started to come out, and I wanted to show you some of this is just recent publication of Time magazine. And then the whole issue is on coronavirus. And there's one interesting article, and then this article talks about that when will we get a vaccine? The whole world is waiting. If you talk to someone in Pakistan or India or Germany or Africa, the first thing comes to their mind and they ask you, so tell me, when would we see a vaccine? So it's a very complex issue. People have died, families have been lost, but at the end of the day, we all know that a lot of researchers in Europe, in United States, they are working hard, like these 2 guests, just to do something where we can deal with this virus. But at the end of the day, what we are seeing is we are seeing a lot of geopolitics being involved. And then Wall Street alone by March had lost $3 trillion. I mean, it's a very big money. So by end of March 31st, 3 trillion were lost. There are companies, they have lost $1 billion, but eventually they will recover. As we know, consumption will come back. Consumers are not going anywhere. Eventually markets will come back, but the process is very disturbing. and we are witnessing a lot of disruptions. So these are my comments. We can go on forever, but there is another publication which is called Politico. I just made a copy yesterday, and it talks about here is how the pandemic finally ends. But they are talking about all kinds of issues that after vaccination, we have to wait to prove that it's working. If you are a scientist and you are providing a vaccine, your job is to also make sure that the day after is okay. And then there's another statement they made here, and they say that the years-long outlook, they might get the snaffle, the world will probably live with coronavirus 19 forever. For how long, we don't know. But it will be determined in the labs. It will be determined in corporate headquarters how much money you allocate to fix this. But to provide $2 trillion under the CARES Act, that was a very ambitious decision on the part of the United States. And what we saw in the last 6-7 months, I think I never saw in my whole life. I mean, we were all grounded, but eventually we will come back. At this time, I would close, but let's open this floor for your questions. We still have 15 minutes. So I will ask our guests if they can come here. And if you have any questions, Luis has his mic, so he will bring the mic to you if you want to ask any questions. Any questions, comments? Dr. Almas has questions. Go there.
I have a very nice presentation. I really enjoyed your presentation, and it's relevant what we are going through. Everybody knows, and with all the deaths and challenges we are going through. Really appreciate your time coming into Dr. Anwar's class, and he invited me to come here. And I'm also interested not only from the health point of view, but also from agriculture point of view, because it has a major impact on agriculture industry. My question to Dr. Hunt is that what's the cost for that copper clean? Is it commercially available in the market, or you have to place order or something?
It is commercially available. So the universal patch is about $30. Yes, so it's just to give you, and it's about a little over 3 inches by 5 inches in size. So the latch patches are less than that. I think that online they're maybe $24.99 or something. That's the latch patch, which is the handle one. So
what my understanding is, it's pretty economical.
it is, and that's if you're buying one patch at a time. But when we do orders for school systems, it goes, of course, way down based on bulk orders.
So there is a discount on quantity.
Yes.
And is it what is the cost associated with that for producing it? Who produces it? Is it a commercial company, or is it WT's business or something?
So we do produce it. So we have several different manufacturing steps along the way. Like I said, they actually all occur in the U.S. right now. It became really important, as we talked about, we stopped being able to get supplies internationally. And so we had to revamp a lot of what we were doing to find what we needed here in the U.S. Of course, we're paying a lot more for that. We have several different steps, but we do the final processing step is done here at WT. So that's what I'll say. But it happens all along. I mean, like we have the raw copper goes to a specific refinery that takes it down to a certain thickness, and then we alloy it at a different location with our different materials, and then it's cut, and then the final processing is done here.
So is WT making money, or is it just for the good for the humanity?
No, that's a great question. So yes, we are making money, but the money that we're making goes back into the research, the graduate students, and so it's a cyclic kind of setup that we have. But it's been very beneficial for all of us.
Thank you. That's a great project. Thank you. Appreciate it.
Other questions?
I was wondering, I saw on the copper clean as well, like, is there restaurants and places here in Amarillo and Canyon that are using them as well that you know of?
Yes.
Yes.
In Canyon and in Amarillo.
Oh yeah, because the only place that I've seen him was here, like at the school. And then I remember first coming here, whenever I was seeing it, just wondering about it, what it was. So I was happy you were here and explain a little on it. But yeah, so I was just wondering what other places that you knew of that was doing it for sure, and if y'all were trying to expand it towards more restaurants, because I am a server and a manager at a restaurant here, so it kind of had me a little intrigued about it.
Sure. Yes, I would say so. Some local places that you'll see it are like there's several coffee shops in Amarillo, Palace Coffee in Amarillo, Chick-fil-A. I should be remembering more of them on the spot, but we should talk because we can definitely get it.
Yeah, for sure.
But we've seen we had a lot of early adaptation in the Metroplex. So the majority, I would say, of our early the people who actually really bought into it, it was more widespread within the Metroplex than it was here. But they had a little bit different perspective on the virus itself, I would say, than what we did here. So.
Thank you.
Thanks, man. Another thing on the copper fit, I was wondering why it's like, I know it's the size of like your hand or whatever. I just feel like if you can always like miss the handle just by a little bit. It just, why don't y'all just like make handles or for bigger surfaces? Because I saw a whole rail with just like one part of the copper fit. Like, why can't the whole rail? Is it just?
That's a great question. Typically, what we do is we try to optimize cost and application. So we are even doing some projects right now for some protein plants. And so they have like miles of railing, and they're looking at like what would be a common, it's ergonomics. You start looking at the cross between engineering and business, and you look at, okay, how many places can we put it to get the most touches for the least price? So I would say most of the time, because I can make it as long as you want it to be for the most part, but when you're looking at that from a business perspective, again, you're looking at what do I really want to spend and how can I cover the most ground spending the less. There are companies that make handles from copper. So years ago, before stainless steel became so popular, hospitals, their handles were made from copper. The hospital beds, a lot of the structure of the hospital bed was made from copper. It was used in these ways. It's heavy, it's costly compared to stainless steel. And so when stainless steel came out, and stainless steel is kind of a self-healing metal in a sense, then that became the most widespread. And part of it for stainless steel was the way it looks.
Yeah.
So copper doesn't look great to people after a certain time. And some people don't like the color, like the kind of orangey color. There's all kinds of things that you wouldn't think from an engineering perspective, I wouldn't think factor into the purchase of a door handle. But it does. It does on a very large scale. So they stopped using copper in the medical industry because stainless steel became so readily available, so cheap, so easy to use, easy to clean. But I think we'll see a comeback. I think we'll see copper come back into a lot of different industries.
So there is a possibility that there could be a copper coating for.
Yes, there already are copper coatings. There are. It's just not taken off. So, and copper coatings, or even doing something like the adhesive that we do, it makes it where you can retrofit what you already have to be functional instead of having to replace it, like we will eventually with an actual door handle or something.
So, like, I know y'all are a business, but are y'all like publicly traded? So, like, if someone wants to invest or something, it's even if it's through the university.
That's a great question. We actually have private investors, so it's privately funded.
Okay.
Yes, and the university is also, they do own part of it, but yes, that's a great question.
I have a question to Dr. Bouma. So there was a comment the other day somebody made. So after a coronavirus, you may see another virus on the screen in the pipeline showing up. Can you comment on that? Because it may not be.
Yeah,
Another
different,
type of
a different virus
That's
than
right.
SARS coronavirus 2, sure. So animals are natural reservoirs for many viruses. And sometimes, depending on the similarity between the animal tissue and the human tissue, it may not take many steps of mutation, say many successive mutations, to produce a virus that could, quote unquote, as they say in the field, jump from those animals to humans. So there's some areas in the environment, some areas on the globe where many different animals mix, say they share a cave or some other habitat where the animals are mixing a lot, and that makes it easy for these viruses to jump or to move from one organism to another. And so that, that's Ebola is another example of a virus that is a zoonotic virus, normally inhabits bats and some other species that can jump into humans.
But there was a study lately, and they said that there are many types of mutations.
Yes.
Can you comment on that? Because they said they never saw it, but in coronavirus, it's just out of control.
So you're referring to different viruses than
In different
coronaviruses. Yeah,
countries.
yeah. So probably the main kinds of mutations that would occur would be ones that allow the virus to bind to a human cell using a protein that's similar to its normal mode of entry in that animal. And normally the human version of that protein and the animal version are different enough that that virus won't affect humans. But it's possible for mutations to occur. I don't know specifically which virus to which they may have been referring, though.
Okay.
I have a question for you. You talked about 2 different types of vaccines.
Mhm.
Which one do you think would be most effective?
Okay, so I'm not specifically a virologist and not specifically involved in the vaccine development. So I'll just comment on each side. So the value of using the adenovirus vector for the vaccine is that you can put a different gene in there, say the spike protein, and have that expressed in the human. And then when that virus reproduces and is shed among, say, that person's close contacts, then you do get herd immunity. And that's something that's used all the time in agriculture, right? But there is some risk of that particular kind of vaccine causing, a more severe illness in an individual who receives it, say if that's an immunocompromised person or something like that. The RNA vaccines literally contain the one gene encoding the protein to be the antigen, but they are effective only in the individual who is vaccinated, and typically because there's only that one antigen present, there may be 2 shots needed. So hence you go back for a booster in a couple of weeks or something. And that's part of the logistical issues with this particular vaccine is if one of the quote unquote best ones is one that requires a booster, say 2 shots, then the person has to follow up and has to go back to get that second shot in a timely fashion.
Okay.
So that's
Okay.
that's the difference.
Well, before we conclude, I just want to thank.
There is another question.
Oh, yeah. Okay, go ahead.
Well, I had a question for Mrs. Hunt about the longevity of your product. How have you ran into problems with that, or?
That's a great question. So what we say is the material is functioning as long as there's copper present. From an engineering perspective, the weakness is going to be in the adhesive. So how long can we get it to stick? We've worked with 3M very closely, and so right now they're really hard to get off. We're advertising adhesive for up to 2 years in an extreme environment, so with large temperature swings. But the copper will always be functional because it's inherent as part of the copper material.
Okay, we are coming to a point where we have to finish this seminar, but I sincerely thank our 2 speakers, our colleagues from West Texas A&M University, and I also want to thank our students attending this. And Luis, thank you so much for all your logistical help. You have been running around in the room. Before we conclude, this kind of topic will never finish. Just like financial crisis, we have 7 seminars. So in this also, we will continue this discussion hopefully next semester, and we will invite you again to tell us what happened and what may happen in future. but this is a never-ending topic. But I purposely selected the word global perspective because this is not restricted to United States. It's a global problem, and it has been dealt with by many countries in their own fashion. So that's why it's a global crisis. But eventually, as I said before, the crisis will be over in 1 year, 2 years, and we will come back to normal, and we will have our wonderful things again. But at this time, we are going through this crisis. So please keep wearing your mask. And thank you again, and goodbye from West Texas A&M University.